Right.
Okay, this is our lab 5, team 6. This is the region of operation for bipolar junctions and transistors. I'm Shina Delicun.
I'm Daniel Rubio.
Junior Luxon.
We would have Mark, but unfortunately, he's not gonna be in this lab for us. He did contribute with the slides and the teamwork and support. But he had other obligations to go to at the moment. But so far, this is what we have right now. These are our objectives. Our objective is to review the basic MyDoc, MyDoc function capabilities. We're going to use MyDoc to analyze the behavior of the circuit, to measure the voltage and current of the circuit as well. And basically just to understand the concepts of here and there and the use of Multisim and our MyDocs.
This is activity 1, the schematic diagram, where we have 2 resistors and 1 voltage. In this case, is equal to 10 voltage. And according to the questions, we are to find different values.
And these are the values. So for condition 2, when VC equal AP, so basically we are the equations, which can be taken by 0.7 voltage, and that's it.
This is for MyDoc. The only MyDoc activity we have. As you can see, I have the batteries set in, and I have some of the resistors set, and this is what it should have came out to be.
And this is the multisim. No, I think that's for me. But go ahead, you can take it. Go ahead.
This is the multisim, where we have values for voltage on the first one. The second one, we have the 5 voltage, and the third one and last is 8 voltage. They both run the same.
Okay, so this is the schematic diagram. You use the same circuit. This is the equation. You measure the VCL, VRC, and VKC, and that's what it gave you.
And this is our multisim for the previous slide. As you can see, where it reads off the 634.483 for the XMM2. For the XMM3, we have 657.753 milliV. And for our third one, not the third one, but our first one, the XMM1 millimeter, is measured to be 23.27 millivoltage as for the multisim. And you can see how we connected it all with multisim and the resistors we have to put.
This is activity 3, the schematic diagram, where according to the question, we are to measure VCE, VBE, VBC on the following conditions, where RB equals to RL and RB equals to 1000 RL.
So this is the multisim for activity 3. This is the resistors, and let's see, the RB equals 10K ohms, and Q1 identical to the other 5. So that's it.
And this is the activity 4. So basically for this figure is the MPN, the MJT bias with the resistance RB connected from its base to a DC voltage source. and its load resistance RL from its collector to the same VDC voltage source as well. Basically, we're doing a repeat. As you can see to the side, that's the equation that we got. That also is helpful with the one from the previous activity. The VCC is not equal, greater than or equal to the 4V, and the VCC is 0.5 VEE. And we have the greater than, or it's either greater than or equal to the 1K ohms to the RL. And what we have also here, the RB is equal to the RL, and the RL equals to, well, comes out to be 1,000.
Here we have the multisystem, where we have the values for the resistors equal to 1K ohms, 678.02 MV, 22.139 MV, and 700.167 MV. And for the second one, based on the question, we have a negative 3.062 V, 3.683 on the resistor. And for the other one, we find no value, it's constant.
For activity 5, the schematic diagram, and you set up the following circuit, which is VCC greater than or equal to 4V. So if you measure the 1K ohms, you measure the VCL, VL, VREV, you see for the following, and that's what it gives you. That's why. You can go ahead and move forward.
Thank you. And this is our multi-sim for activity 5 as well. This is what we got. You see the values below. But from the multi-sim itself, we have some negative values from the X. From basically, we have negative 16.024 MV, 659.43 MV, and 675.462 MV. And other one to our right that we see is negative 2.799 V, positive 613.108 MV, and then we have 3.412 V. And you can see that with the equation that we have below at the bottom, we got RB equal RL equal 1K ohms, and the other side is RB equal 1,000 RL. And excuse me, we have VCE equal to 0.68 V, VBE 0.67 V, VBC, as you can see, negative 16.02. And basically, it's basically the same values that we have, the same things brought up in the bottom is what we have in the multi-sim itself.
Here we have activity 6, a schematic diagram, where we'll be measuring VCE, VBE, and VBC.
For activity 6, this is the multi-sum, and the RB is 1, and OL is 1 ohm. The resistor is 10 V, VCC, as you can see, these are the results below. VCE 9.99 V, VBE 0.48 V, and VBC negative 9.51 V. Can go ahead and move forward.
And in conclusion, what we learned is that how our bipolar junction transistor work, and we calculated how, according to the analysis we got from the circuit, and with the results from my doc, which we only used once for this lab, we closely looked at the range and compared the values and calculated and That's for lab 5. Thank you very
Thank
much.
you,
Thank you,
Professor.
Professor. Have a good day. Lab 6.
Still
I
messed
like
us.
that. I like that.